Hello. So today I'm going to do another box from TryHackMe.com. Today the one we're doing is dogcat. It describes itself as a website where you can look at pictures of dogs and or cats. This one is a little different than Active Directory, the last video I made. The only task listed on here is for the flags found on the machine. There are no steps walking you through anything, so that's probably why it's marked as a little more difficult. I've already started up the VM and we have the IP address, and we can see we're already connected to the VPN network. So let's go ahead and get started. First, I went ahead and ran nmap just to save some time. And the scan came back with 2 ports open. So we have 22 SSH showing that it's a Ubuntu machine, and 80 with HTTP and Apache web server running, and with the title of dogcat. Both of these versions look relatively new, but we can check them real quick just to kind of get a date. So we see Launchpad, this was in 2020, 2438, 2.4.38. Yeah, so 2019 of last year, so it's still a relatively new distribution of Debian, so everything's most likely up to date. Moving on, we can take a look at the web server. Let's copy that IP address real quick. And on the web server, we get a mostly blank page with just 2 buttons here for either a dog or a cat. The source doesn't give us much. It just shows there's a parameter being passed. If you click the button, if you click on dog, it changes view to dog. Click on cat, changes the view to cat. So if we try it, it just generates a random picture of a dog with a really big picture. Not sure what that is. But if we look at the source now, we can see the image that's being generated is in the dogs folder, and it seems to be just a random JPEG file with a random number name. And the same thing happens for cat. So cats and then 10. So based on doing this before, the number is most likely just anywhere between 1 and 10 or something like that for the random number. But what's interesting is this parameter being passed here. So a lot of times what we can do is, Apache is usually running PHP, but we might be able to verify it by checking for index.php, which does load this page. If we try .html, can't find the page, so it does confirm PHP is what's running the server. If we go back to the parameter here, usually the index.php file is going to be in the same directory as this file that's running here, so we might be able to, what might be happening on the back end is this parameter is appending a file extension, so probably PHP, but we'll have to see in just a little bit. So if we tried index, we get an error that only dogs or cats are allowed, which means there's some kind of filtering here to prevent local file inclusion. What we can try though is, we saw the images were in a dogs folder, and we know, say, dogs 4 existed. Then we get a PHP error saying that dogs4.php right here doesn't exist. So that does confirm it's adding the PHP tag to the end of the file. What if we... There's another technique called a PHP filter, or it's a built-in function of PHP. So if we do a quick search here, essentially what we're going to do is we're going to use this filter to read PHP files on the server, whereas this is not going to let us read something, but if we wanted to read, say, the index.php file to see what it's doing in the background that's not showing in the source, we can use that to base64 encode it to get the PHP code, decode it, and then see what's happening. We do need to be able to find a file first that we can read. So we go up to the dogs folder. If we go back another directory now, so we're back in the root directory, what if we tried index now? So now we get a different error. We're not getting that we can only use dogs or cats now. Now we're getting a different error. So let's try reading that with the PHP filter. To do that, we say PHP filter convert.base64-encode resource, and the resource is the file we want to look at. So let's say dogs, we're just going to use the same path we just got an error for. So dogs dot back to directory, and then looking at index, and this should append.php to it. So if we do that, we get this long string of base64 here. It goes on for a while. It's kind of hard to read like this. So I'm actually going to do this in Burp Suite to make it easier to go back and forth. So we get started up here. Okay, so Burp Suite is set up as a proxy. It listens by default on port 8080 on the local host, and the intercept is on, so now we just need to get our browser to go through the proxy. I'm using an extension called Foxy Proxy that's already set up with Burp Suite, but if we look at the options, I'm just telling it to go to localhost and use port 8080. This extension just makes it easier to turn it on and off. So if I use this same URL again, you can see it gets passed over to Burp Suite. This is just the request. It hasn't actually come back with anything yet. I could forward it and it would come back to the browser with this same result, but instead I'm going to send it to repeater, and then we can send it and do it multiple times without having to catch it each time with the proxy. So now that we have that, I can turn off the proxy so it doesn't hang anymore, but we get the same base64 result here. So if we copy the base64, Burp Suite also has this useful decoder option here. We paste in the base64, choose decode as that. You can see we get some HTML to make it easier to read. If I throw it in here, it looks like we get the whole website, or the whole web page. So we get the basic HTML, but we also get the PHP code. This code didn't show up on the source code before, because anything within these PHP tags, the question mark caret, is being executed by the web server and is not displayed in the source code. So if we dive a little closer into this, we can see that it's looking for two parameters that are being passed to the server. One is the view parameter that we already know about here, that's taking the file that should be displayed here, and that one is looking for either dog or cat. And if one of those is seen, it runs dog and then adds an extension, which is the other parameter. So if the extension isn't provided, or if the value for the ext parameter isn't given, it automatically adds .php. So here, if dog is chosen, it makes it dog.php, and the same for cat.php. What we can do with this is, now that we know there's another parameter that we didn't see before, we can choose a different extension to read other files on the server, or to try to. To experiment with this, we can go back to repeater here and try to get a different file. So if we see, what if we just tried dog, since we know this should be dog.php. We get some base64 again, and here we can see it's just loading an image from the dogs folder and using PHP to generate a random number between 1 and 10, add JPEG to it, and then display it. So that explains how the website is working here, how it's just choosing this picture. Now that we know we can read files on the server, we might want to try to do something more interesting, like maybe read the etsy.passwd file, which contains the users that are on the machine. I'm actually going to get rid of the filter since we don't need to read PHP code anymore. So if we do this, we still want to go dogs and then come back one. And this number of ... slashes here doesn't really matter. For the directory traversal to work, we just need to go back enough to get back to the root directory. For example, in the one I'm in here, I'm in the home, flick, TryHackMe, dogcat directory. So if I go back 3 directories, I'm still in home. So I need to get all the way back to the root directory to get to etc.passwd. So I'm just adding a bunch. It's just a lot to make sure that I go back to just the root directory. So if we look for this, we get an error that passwd.php isn't able to be opened, which makes sense given that in this file we can see that if we don't provide the ext extension, it automatically appends PHP to it. So we're going to add the extension parameter here and just leave it blank because passwd doesn't have an extension. So if we do this one more time, you can see we do get the contents of that file and all of the users that are on the machine. So remember the root, daemon, all the basic Linux users. Great, so now we can read system files. What comes after that? What we can put together from what we know so far, we can read system files and we know there's an Apache web server running. What if we can read the Apache log files? So if we switch etc.passwd to be something like var log, I think it's apache2 access.log. Although if we do this, we're going to get an error. So if we run this, oh, apparently not. That works. So what I was expecting is that access.log would have PHP appended to it and the file name would be ended up being access.log.php. But since I left this blank, it's just reading this as the full name, file name. If I remove this, however, then we get the error message saying access.log.php doesn't exist because that's not actually the name of the file. We could also do it a different way and just leave it as access and make the extension .log. So this should load the same file. And this is just the content of the access.log file, which shows a log of essentially anyone who's accessed the web server, the resource they were accessing. I'm going to actually change this over to the browser to make it easier to read. We'll go to the source. So now we can see all of the events for me accessing this web server. So you can see I'm getting this page, passing this parameter, the response code 200 exists, the content length, and my user agent. So there's a common attack or common web attack called log poisoning, where if we can read web server files like we can here, and if we're able to inject executable code into this, for instance, if we're able to put PHP code into this file, when we read the file here or access it like this, it will, instead of displaying it on this page, it will execute the PHP code on the back end. So if we want to try that, we need to somehow get PHP code into this file. And the easiest way to do that is probably going to be through the user agent file or header here. So what if we tried, I'm just making it output so I can make it easy to find in this file over here. And then we'll say PHP system, which will execute just a system command. And then we close out that question mark caret. So for the system command, we just want to say, who am I? And what I'm expecting is to get a result of www data or something like that, giving us the username of the person, of the user account running the web server. So if we send this and then refresh the page, search for output, and we get output www data. So see, we don't get the PHP code, we just get the result of this system command being executed. which means we have code execution on the server. So we can do something else like adding other commands in here. I'm going to change this slightly to be $_request. Basically, I'm going to add a new parameter we can pass to this URL that'll let us just change the command in the URL rather than having to send a brand new PHP command every time. So we'll say cmd like this. So the system command is still going to execute, but it's just going to execute the value that's passed to the cmd parameter when the page is requested. So if we change, say output 2 for that, and if we look for output 2 after refreshing the page, we get output 2, but it says it can't execute a blank command in access.log. But that's just because I haven't given anything to that command. So if we add another parameter here and say command equals ID this time, when we look at it, this time we have similar output showing that we're www data and the groups and everything for that user. So now we can do something else, like we want to get a reverse shell. So what we need to do is find out what software is available on the machine to give us a reverse shell. So one of the usual ones would be bash. So we can say which bash to see if it's on the machine. So bin bash does exist. Or even better, which netcat. But that result is blank, so netcat doesn't seem to exist on the machine. Or even maybe sbin netcat. Sometimes it's in a different place. No, still not there. So from here, I'm going to go to reverse shell cheat sheet. And we're going to take the common bash one at the top here. We'll just use this file to change the parameters around a little bit. We'll say port 9001 and my IP, which is 10.2.14.105. 10.2.14.105. We'll copy this. Go back to the CMD here. So this reverse shell is just going to use bash to create a network connection to my IP address on this port. And for that to work, all I need to do is start a listener on this machine running on port 9001. So I'll start that with Netcat, and I'll run this command. However, we don't actually get anything calling back. And that's because there's some kind of filtering on the server that's preventing callouts this way. There are several other reverse shells we could try, some with Python, PHP. The way we're putting it in here in the URL and the fact that these need single quotes, double quotes, it causes some issues. I haven't been able to get any of them to work. What I did instead, since we know the web server is executing PHP, there's another method that I've used pretty often and I like. If we say PHP reverse shell GitHub. This first one from Pentest Monkey. So what we're going to do, essentially this runs a PHP reverse shell, but it runs it through a file that if we can get the server to execute the file, then it'll do the same thing and call back to our machine. So I'm just going to copy this, save in, we'll call it rev.php to simplify it. We'll actually go back into dogcat there, vim rev.php. Okay, so we have the contents of the file. We do need to change a few things just to make sure it comes back to the correct IP. So we'll change this to be 10.2.14.105 like we did before, and I want it to be on port 9001. So that should be all we need. We'll save that. And what I'm going to do is first Python 3, and we're going to start a web server with Python, and then we'll use wget from our command execution here to download the file from my Python server into the root directory of the web server, so that what we would eventually want to do is we want to have it stored here, where we can access it at the web server at rev.php. That way when we visit it, it executes the command and it calls back to our Netcat listener. So first we'll start up a web server. Since I'm not the root user here. There we go. So we have a web server running in this directory on port 80. So my command here is going to be wget http 10.2.14.105 rev.php, and we'll output it to var www html rev.php. That should work, I believe. However, that doesn't work. I don't believe wget is actually on this server. Yeah, so we don't get any output here. But that's okay. We can change it to curl. It essentially serves the same purpose, so user bin curl does exist. So here we'll make it curl http 10.2.14.105, same file, and we'll output it to. So we're going to var www html because this is the root web directory, the default root web directory for Apache. And before I do that, I can validate that that's where the rest of these files are stored. If we run lsla and then come down here, we get the contents of that file or that folder, which shows us cat.php, dog.php, index. So this is the same directory we were seeing all the other files in earlier. So if we curl and output it to that directory, call it rev.php, you can see my web server does get a hit over here that it was downloaded. And so we'll go back and read the contents of that directory one more time. Right? Did I mess that up? var www. There we go. So we can see now rev.php is stored in this directory, and we can confirm that it's the same file. If we look here, the length of my file is 5494, which matches 5494 for this file. So now all we have to do is visit this page, and the reverse shell will be activated. So first I need to listen on port 91 or 9001, visit the page, and there we go. We have a callback from the server, and we're the www data user. So now we have access to this machine. However, we're going to run into another issue. This .docker environment gives us one clue, but also if we look at hostname, we have kind of a random name here. This naming convention is common for Docker containers, and this .docker environment also gives us another clue that we're in a Docker container rather than the actual server we're looking for. And so many of our commands are missing. Anyway, what we need to do now, first we need to escalate permissions to the root user on this machine so that we can search around files and see what we need to do to get to the actual dogcat VM that's hosting the Docker container. To save some time, we would normally look at a couple of things like SUID files, which is what this would be, and we'll say to dev null. So this is searching the whole file structure or the whole Linux directories for files with the SUID flag set, is what the 4 means, a file type, and it's just going to give us all the information about it. So these are all the SUID files on the machine or in the Docker container. There isn't anything out of the ordinary listed here though. So what the next step would be seeing if this www data user can run anything with sudo, which when we do sudo -l, we do get that it can run this command, userbin env or env for environment, as root with no password. So that sounds bad. Running anything as root with no password is generally a bad idea. So we'll go over to GTFO bins, which is really useful. Just a list of Unix binaries that can be exploited one way or another. So if we search environment, we can click on it and we can see sudo, which is what we're doing here. We're going to run it with sudo. It says it can be used to escalate privileges and run any file under the context of that user. So if we do sudo bin sh, we don't get a response, but if we check now we're the root user on this machine. So now we can poke around a little bit, but again, for the sake of time, the important pieces that we're looking for are in the opt folder. We have a folder called backups, which is not standard. So if we dive closer, there's a tar file here. It's pretty large, but there's also a bash script called backup.sh. If we take a look at that, it looks like all it's doing is using tar to back up the root/container folder into this tar file. And based on where it is and how it's set up here, it looks like it's automatically being run from whatever the host machine is to back it up. If we look at root, we can verify that /root/container doesn't exist here. So these directories are probably on the host machine. There are also flags. I'm not going to cover what's in the flags, but we can look at them to put over in here to get points to complete the machine. So what I'm going to do, we're going to go back to opt backups, and under the assumption that this backup.sh script is what's being run regularly to create this tar file, I'm going to edit that file to instead call back to my machine with another reverse shell to the host machine. So first, we'll just echo bin bash into backup.sh. That will clear everything that was in there and give us the starting point for what else I'm going to add, which is going to be this same bash reverse shell that we used before, but now I'm going to make it 9002 since we're already using 9001. We'll add that, and we'll echo that into backup.sh. But this time we're appending. The double carets means we're appending onto the file instead of overriding it completely. So the entire file will now be bin bash and a bash to create a network connection to my IP on port 9002. So the last step, if I start another listener on port 9002, you can see that file still exists. It was changed by us just a few minutes ago. Now we just have to wait for it to automatically be run by the host machine. It shouldn't take very long, so we'll give it a minute. If not, I'll speed up the video if needed. And there we go. And now we can see the host name looks like it's dogcat and that we're the root user. So we can confirm that we're root and the host name is dogcat. And we could get flag 4, which is the last one, indicating that we're at the end of this box. Okay, so that's all for this video. If anyone has any questions, leave a comment or let me know, and see you next time.